Hi all, just a quick video to show you guys what we did the other day. I figured this is the simplest method rather than me trying to send a whole pile of emails. But if there's any questions that come out of this, just send me an email or send me a number and I can give you a call. So very quickly we'll go through just the basics of rocket theory. So with any rocket there's two things you really need to worry about. You've got the centre of gravity and then centre of pressure. Centre of gravity, centre of mass, just the point at which it balances. Centre of pressure is the point at which the aerodynamic forces acting on the rocket are considered equal on both sides of this. Centre of gravity is quite easy to measure, just a matter of balancing it. Centre of pressure is a little bit more difficult to do. You can do that, just while I remember, we'll open this up here. There is free software called Open Rocket. You go to Open Rocket here, you can download that there. There's good tutorials online you can use to model your rocket and actually predict how high it's going to fly. That was how one of my students did it, who builds a lot of rockets. He worked as one who was going to get to about 240 meters, and it was pretty much bang on, so quite an accurate simulating software. This software here does the calculations for you for doing the centre of pressure. Otherwise, you're kind of just guessing a little bit, and that just kind of goes off just looking at rockets to get a bit of an idea. So for example, this one here had a pretty well-balanced centre of pressure and centre of mass, and in terms of the distance between the two, you need about 1.5 diameters. So if this is my centre of mass here, my centre of pressure needs to be probably around about here in order to have a stable flight. If it's above that there, it'll fly uncontrollably. So an example of when you have the opposite effect as well, if you've got one which has got too large a centre of pressure down the back, like this one here with massive fins, the centre of pressure is way back here, centre of mass was further up here. This one flew too stably, and what happens in this case here is if it's going, when it takes off, if there's wind, what happens is the wind then, as it's blowing, it pushes this here and it flies off into the wind. It's called wind vane, or wind cocking, or wind vaning. So you really want to have those two balanced. But as I say, generally you want to have that centre of pressure 1.5 diameters of the rocket behind the centre of gravity. But yeah, so even with this software here, it does the calculations. It tells you if you're going to have a stable flight or not. Now, in terms of the construction of these here, the motors we use is a large variety of motors you can get. These are the ones we used here. They have the first number here is the impulse, and the next one is going to tell you the time delay. So there's a huge amount of variety with these ones here. These ones here were extremely quick burn. They were only burning for about barely a second, not even that, probably about 0.6 of a second. So there was almost an explosion going off the pad in terms of their speed, which came with the advantage of if the student had made them if the rocket wasn't stable, it was over pretty quick, and then it was just floating down out of the sky rather than having one which burns, say, 3 or 4 seconds, and then if it's going wrong for a lot longer. To get these rockets, let's grab these here. The way we built them is these tubes here came from I asked our cleaners to collect these up. These are just paper towel holders. And then inside them here, down the very bottom, this is where we put the rocket motor. The rocket motor is held in. We use, just because we've got a 3D printer here, you can just get away with just using cardboard, as this group here did. That's made some centering rings with some cardboard rings like that. It worked great. But just to speed things up, because one of the classes was a little bit behind, I ended up printing up a couple of different enclosures for these here. So this here held it centered, and then I just glued that inside here like so. To attach, actually we'll talk about the parachute next. So the parachute here, this was just made out of a rubbish bin or bag, and the way we did this was we cut a square out of the plastic, and then we just folded this over and over and over like so, until it formed like quite a sharp cone shape like this. We nipped a bit off the end, off the sharp end here, just to allow some air to go through the parachute, which makes it stable. And then we cut off the end here, and when we did that there, we ended up with a nice parachute. This size parachute here seemed pretty appropriate. There's a fair bit of tolerance with these, but this seemed to work pretty well. To attach the strings onto this, the strings are about 90 centimeters long. We used 3 lengths of 90. And then they ended up with 6 strings. We just taped these on, so we had tape coming around here, tape up onto the other side, and then we just tied a knot onto there. To attach the parachute to the rocket, what we did is we drilled a hole through here. This is some Kevlar string you can buy from Aliexpress. It's just kite string, quite cheap, just quite handy because it's flame proof. So we just poked the string through here and then fed that out here, and then we just got the hot glue gun and just mashed it against the side, and that stuck it on really, really well. Then we had the so from this rocket up to the base, or to the attachment point on the parachute, that's about 60 centimetres there. And then from here, from the parachute up to the nose cone, you're looking at about 25 centimetres. Again, not ridiculously crucial. Around about that sort of metre length from the nose cone to here, that's plenty of space for the shock cord there. For the nose cones, there was a variety. Some students decided to make their own, but again, just to speed things up, I did print off a variety of them. If you don't have a 3D printer, there are ways to get them printed pretty cheaply, and I'll show you that now. So what you can do is, this is the software that I regularly use to do my 3D modelling. It's Onshape. Quite a simple software. So what I did here is I just go to that there, I drew a sketch of the nose cone, just a half of it, and once I clicked on this here, actually I'll show you the full process there, so I'll get rid of that there. Alright, so there's many ways to build these things here, but what I did is on one of the planes I drew a sketch, and then from that sketch there, then I selected that and then I hit revolve, and then it's going to revolve around, select the axes, this axis here, and that creates the nose cone from there. This is completely solid at the stage here. What I do is I then go up to here, which is a shell, and then I put the wall in at 1 millimeter should be enough. Did I get that right? Yep, and at that point there, now you've got a 1 millimeter shell. So from here, we can then export that. And if you're exporting as an STL binary and then units and millimeters, you end up with a file which you can then print. So that's now in my downloads. If you don't have a printer, you can, as a service which I use quite regularly to get circuit boards printed, but also 3D models. I'll show you here. So this is jlcpcb.com, and you go to 3D printing. From here, to load. It's order now. Okay, so I'm going to add the file. The nose cone, that's the one I wanted to print. So it's just going to process it. Sometimes it can get stuck at 48. Yep, I think it's going to be fine. Come on, come on, come on. Bit of a note here, you're not allowed to print parts of weapons. Occasionally they do ask questions. It does kind of look like a weapon, but they're pretty fine. As soon as you let them know you're at a school and you send some evidence of that, they're fine with it. So the cheapest way to print this here is if you're selecting the SLA resin and then you click Resin X. This here is just, they can just print it with any resin. They're just going to fill it on a build plate. This is by far the cheapest if you don't care about a particular style. And you can see there, to get that print there, you're looking at this is US dollars, but 45 cents. To get that ordered, the cheapest way for this one here is a global direct line. And then you're looking there at a total of, what, $2 US to get that shipped. Usually it takes about 2 weeks to get that done. So as I say, including taxes and all that sort of stuff, usually you can get the nose cone sent to New Zealand and printed for you for around about that $3 mark. So that is the nose cone there. For this one here, I didn't have any special attachment points. I just hot glued the string down inside there. Oh, the motors, you can get these from Aerospace Education. Aerospace Education, Jerry there is pretty good at helping out with that. Often it's easier just to call them up and just talk to them about what you're wanting to do. They are not too cheap, this particular one here. The prices are getting a bit more as time goes on, just because it's getting hard to import explosives into New Zealand. But you still can get them. So Jerry has them, but if you talk to them at different model shops as well, they'll often be able to either get them for you or point you in the direction of someone else who can do that. Let's look at my list of things I wanted to cover. Okay, so when it comes to launching, let's go back to here. Where you want to go for this here is to this document here. So hopefully you guys already know about it, the Safety and Science. So if you're MOE lab, that's meant to be safety school, that's what I googled, first link which comes up. And here, if we jump down to the rocket section, and let's jump ahead to the rocket. There we go. So under section 35.5, it goes through talking about how to do it. I've got all the instructions. I've got a layout diagram here showing you how you pretty much should be doing it. So there's a large variety of ways to do this here, but this is a pretty solid walkthrough here. The one thing which is a little bit of a weird quirk they've got in here, and I think it's just because the person who wrote this possibly didn't understand, or maybe they did understand but weren't that clear, saying you can't use rocket launchers containing explosives class 1. Now, black powder is a class 1 explosive. There is black powder in the end of this, but it's also impossible to have a model rocket motor without any black powder in it, which is kind of weird because this entire thing here talks about electric matches, the danger of fire and all that. And it's like they're describing these things through the entire way, but then at the one clause there that they're saying you can't use anything which contains class 1 explosives. So I think that is just an error on their part, because they say the rest of this here is talking explicitly about these here. I think they just need to clarify that there, unless they're just saying you just can't use an explosive to blow one of these things into the sky. That's the only other interpretation I've got. But yeah, that's just a little thing to consider there. Oh, actually, the other thing, just while I remember, in terms of fire safety, when you've got the rocket, when you've got the parachute down inside here, before you put the parachute in, because there's a small explosive charge which blows out the parachute, you get wadding, so this is just flame-proof tissue. You put a couple of bits down inside there and it'll be fine. So I think that's that. In terms of extra support with this, you probably saw on the physics page that John Smith is talking about having another rocket day. As much as this video is probably going to give you a bit of an idea of what you're in for, it's very advisable to go along to one of those days or talk to the NZRA, the New Zealand Rocketry Association. We meet down in Oreni every month, and they're more than happy for visitors to come along, especially if it's just a couple of people. If they're interested in doing it with students, they'll be able to talk you through and you'll be able to witness how to do it and give you a bit of an idea of how to actually run a range safely. In fact, I would strongly recommend you going along to at least one of those launches. You can find them if you go, just Google NZRA, let's find it here, NZRA. There we go, New Zealand Rocketry Association. So just be in contact with these guys, join the group, be in contact with these guys. They're extremely helpful. I'm part of the club. I don't go around as much as I would want to, but it's just because I'm quite busy. But yeah, very good resource, well worth being in contact with these guys. Okay, I think that is everything I can cover in a quick overview of what's happening with this. So any questions, just send me an email or give me a number and I'll give you a call.